Hi, Advanced Algebra 2. This is Mrs. Langford, and we're going to go over some notes on Concept 40 today. Just part 1, we're just going to cover adding and subtracting rational expressions. So let's find the sum or difference of these first examples. Now, rational expressions are basically just like simple fractions. We have to have a common denominator in order to add or subtract. So in these first 4 examples, we do have common denominators. So we have 8 over 12x minus 5 over 12x. So we can just go ahead and subtract our numerators. 8 minus 5 will give us 3 over 12x. And then we want to simplify like we did in Concept 39. So we can divide out 3 from the top and the bottom. And our final rational expression after we subtracted would be 1 over 4x. Now let's look at the second example. So 2 over 3x squared plus 1 over 3x squared. Our denominators are the same, so we can just add our numerators. Now we can simplify by dividing out the 3's from top and bottom. So our final rational expression is 1 over x squared. Let's try a couple more. Notice your denominators are the same, so we can just combine the numerators. 4x's minus 1x is 3x over x minus 2. This is in simplified form. We cannot divide out things that are added or subtracted together, so we cannot divide the x's out from the 3x and the x minus 2. All right, sorry about that. Finally, let's go to the last example. Hopefully you're getting the idea. The denominators are the same, so we can, in this case, add the numerators. Now to simplify, I notice that I can factor a 2 out of my numerator. So that is another way I can simplify, is by factoring and then seeing if I have like terms. Now do you see on my numerator and denominator how I have x squared plus 1? So since those expressions are identical, I can divide out the entire expression, leaving me with an answer of 2. All right, so let's make some generalizations about adding and subtracting rationals. So to add or subtract 2 rational expressions with unlike denominators, so we were just adding ones with like denominators. But if we have unlike denominators, we have to find or build a common denominator. Once we do that, we're going to rewrite each rational expression using that common denominator. And then we can add or subtract those numerators. To find a common denominator, first we're going to factor the expressions completely. Then we're going to find a least common multiple and use it as our least common denominator. We'll have to build our common denominators. The least common multiple or least common denominator, you can use those interchangeably, is the product of the highest power of each factor that appears in any of the expressions. And I will explain as we do each example what that means. All right, so let's look at number 1. We need to find the sum, but notice our denominators are not the same. The first thing we do is we factor each of those rationals, numerator or denominator, if we can. So in the first rational, we can't simplify or factor that. But in the second one, we can divide out a 3x from our denominator, and we're left with x plus 1. Now we're going to build a common denominator. So we need a factor from each of the denominators. So I need a 9x squared from my first. Now if I look at my second denominator, I need a 3x. But 3 is a factor that's contained within 9, and x is a factor contained within x squared. So I don't need to repeat it. It's contained within what I already have. But I do need to add an x plus 1. So there's my common denominator. Now to each of my separate rationals, I need to multiply by what's missing from that common denominator. So on the left, I'm multiplying top and bottom by 7x plus 1. Sorry, just x plus 1. And on the right, I'm multiplying each by 3x. Now I've got common denominators, so I can do the math with my numerator. So I'm going to distribute my 7 and add my 3x squared. Now, one final step to simplify is I look and I see, can I factor the numerator? My denominator's already factored, so I leave it. And I cannot. There's not two numbers that will multiply to give me 21 and combine to give me 7. So this is my final answer. Let's look at number 2. Let's start by factoring anything that we can in either rational expression. I can factor a 2 out of my first denominator. And I can do quadratic factoring in my second denominator. X minus 1 times x minus 3 will multiply to give me that first expression. Now let's build our common denominator. So from our first denominator, we need a 2 and an x minus 1. From our second denominator, we already have an x minus 1. We just need to add x minus 3. So now we'll multiply by what we're missing in our common denominator. So the expression on the right is going to get multiplied by 2, and on the left, x minus 3. So let's write what we have on the left then. When we multiply those together, we get x squared minus x minus 6 over our common denominator. And when we multiply the top by 2, we get negative 4x minus 2 over our common denominator. So now we can combine our numerators. We have x squared minus x minus 6, and then I distribute that negative and get plus 4x plus 2, all over my common denominator. Now I need to simplify my numerator, and sometimes this just takes a couple steps. There's really no speeding it up. The more you do of these, the faster you get. I asked myself, can my numerator factor? And yes, it can. I can multiply x plus 4 times x minus 1 to get that numerator, all over my common denominator. Now I can divide out my x minus 1s. And there is my final answer. All right, let's keep going. So now we're going to find a difference on this. So there's no factoring to do, no simplifying in either of these rationals. So let's build our common denominator. Sometimes I give a little illustration of if you're going to a potluck dinner. So you know that there's lots of repeats of dishes that get brought to a potluck, like a couple different dishes of potato salad and a couple different ones of maybe, pasta salad or lasagna. So when you're going along and you're fixing your plate, you don't take one of everything. You pick the best lasagna, at least I do, the one that looks the best to me, and take that. And then we pick, the best pasta salad that looks good. So that's what we do with common denominators. We get each term, but we don't have to repeat. So we need a factor of 4 and 7 and combine those to be 28, and we need an x. So our common denominator would be 28x. We multiply by what each denominator is missing to get 28x, and then adjust our numerators. So 21 over 28x minus 4x over 28x. Combine your numerators over your common denominator. And then we could just write that numerator in standard form. Nothing will factor out and simplify for us. So that's our final answer. Okay, on B, we've got some factoring to do on our second rational expression. So let's factor out a 3. And we're left with, I always mess that up, 3x squared minus 4. All right, let's build our common denominator. So we need a 3x squared from our first term, and then we need a 3x squared from our second term. They're different if they have a term added or subtracted. So let's multiply by what each was missing. and then adjust the numerators. So on the left, we'll have 3x minus 4 over our common denominator. On the right, we'll have x cubed, x times x squared. Now we'll just rewrite our numerator in standard form and take a look at it and make sure that we can't factor it, and we can't. That's kind of a strange polynomial. So there's our final answer. All right, let's do one more for good measure. So first, let's start by factoring both of those denominators. We can factor the first one as x minus 4 times x plus 3. The second expression, notice you can factor a 12 out. Now let's build our common denominator. So I'm looking at both denominators, and I need one of each factor, but I don't have to repeat any of them. So I need 12, I need an x minus 4, and I need an x plus 3. Now let's multiply each rational expression by what's missing in that common denominator. So on the left, we multiply just by 12, and on the right, we multiply by x plus 3. So now we go ahead and adjust our numerators. We're going to distribute that 5 and combine that all over our one common denominator. So let's add like terms. We get 17x plus 15 all over 12 times x minus 4 times x plus 3. All right, that is adding and subtracting rational expressions by finding a common denominator.